What characterizes an oxidation reduction reaction is an electron transfer. So this involves the transfer of electrons. And so we always have one species loses electrons, and something else has to be around there to take those up, so one species gains electrons. And the loss of electrons is known as oxidation, and the gain of electrons is known as reduction. Okay, so we'll look at several examples of that happening. But first of all, we kind of need to talk about what I mean by oxidation state. The oxidation state is really something that helps us keep track of electrons in a reaction. So if you have an ion, the charge on the ion is the oxidation state. Elements have an oxidation state of 0. Think about the oxidation state is that it's the hypothetical charge an atom would have in a compound if the bonding is completely ionic. So, for example, in sodium chloride, it's pretty straightforward. The sodium has a +1 charge, and the chlorine has a -1 charge, because that really is those charges. They are ions, and that's their oxidation states. So this is a +1 oxidation state. This is a -1 oxidation state. And what that means in terms of electrons is that the sodium plus has 1 fewer electron than the sodium atom. And a -1 oxidation state means that chloride minus has 1 more electron than chlorine. So we can treat all molecules like this to figure out oxidation states. So for example, in water, we know that oxygen is almost always going to be a -2, and so that leads us to hydrogen having a +1. And that's going to be one of the rules that we're going to see, is that hydrogen is +1 when it's bonding with nonmetals. But I can also bond it with something like a metal, in which case that magnesium is +2, so the hydrogen is going to be -1, so hydrogen is -1 when it's bonding with metals. Go into a lot more detail about oxidation states and redox chemistry, but we're going to keep it pretty simple, where you're going to be, again, looking for a pattern to identify whether it's a redox reaction. I will show you the oxidation state changes just to be thorough, but you'll learn more about redox when you get into 1.5. So the first type of example I want to show you is a metal plus a metal salt, and this particular example is actually shown here in the picture. You can see that's a piece of copper wire, and it's in a solution of silver nitrate. So what happens here is that the copper, which is copper 0, is going to trade places, is one way to think of it, or replace the silver ions in solution. And that's what that little blue color is that's showing up in the picture. And you can also see that silver is forming on the copper wire. So the copper is becoming a +2 copper, so it's forming the copper nitrate, which is the blue color you see. And then the silver is falling out of solution to become, the silver ions are falling out of solution to become silver metal. And so the copper went from copper 0 to copper +2. It has lost electrons, so it was oxidized. And the silver, which started as +1, has become silver 0. It's been reduced. And so the copper lost 2 electrons, so the electrons are a product. The silver gained an electron, so the electrons are a reactant. And to balance this, I'm just going to put a 2 out here and there, and then a 2 there to balance my silvers and my nitrates. So this is one metal replacing another in solution. And the visible sign that we're looking for is the copper is going to completely dissolve, so we'd actually see a color change, and we see a new metal forming. Okay, so the next type of oxidation reduction reaction is shown here, and there's actually a little video here, a metal plus an acid. So I believe one of those is probably zinc metal. And hydrochloric acid is a common acid we might use. And again, the metal is trading places with the ion. So the metal is trading places with the hydrogen. So the zinc is becoming zinc plus 2 and forming zinc chloride. And then the hydrogen is going from hydrogen plus 1 to hydrogen 0. And that's what the gas bubbles are. Again, our zinc started out as elemental zinc, which is zinc 0, and it's become an ion. It gained 2 electrons, or excuse me, it lost 2 electrons, and then the hydrogen, and there would be 2 of them if I balance. The hydrogen is going from H+, it's picking up 2 electrons to become the element, which is got a 0 oxidation state. So in this case, the zinc was oxidized, and that hydrogen ions are reduced. And the visible sign is the bubbles that you see forming. That's all I have for today. Here's some websites that you can check out to see some videos of some reactions. This acid-base reactions from Khan Academy. And then the precipitation reaction ones that I've shown, they do show the chemical reactions, but they're also just really beautiful the way they put them together. And this science pirate guy, he's kind of funny, so you might take a look at that. So thanks for watching.